Hi, my name is Andrew Magnet, and I'm gonna be talking about the golden ratio, otherwise often called the Fibonacci. So, this was originally discovered back in the good old days of the ancient Greeks. The Greeks believed that the universe was made with mathematical accuracy, and they often used mathematics with philosophy. Like they didn't like there's a certain quote that says something about like if you don't care for math, you shouldn't be in philosophy. Um, so the formula for this thing called the golden ratio, otherwise called phi, is 1 plus the square root of 5 over 2, which is approximated to 1.618. As you can see in here, you have we have a little proof here of it. And example of 233 divided by 144 equals approximately 1.618. You get the golden ratio through the Fibonacci sequence. Like you see here, we have 0, and then 1, 1, 2, 3, 5. The way the Fibonacci sequence works is you take to get the next number, you take the current number and combine it with the previous number. So in this case, we have the first one is 0, then we have 1, but then the next one is 0 plus 1 equals 1, and then 2, and then the next one is 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and so on. Goes on forever. Um, Examples here, and it creates this sort of spiral you see here that goes on forever. And if you look closely, you can see that each and every one of these spirals is equivalent to each other. Like this part right here is equivalent to this part, or congruent, I should say. Not equivalent, it's congruent with it. Uh, so it has a lot of uses. The Greeks used it a lot in their architecture. Like as you can see here, the Parthenon was created forming using the Pythagorean, or not Pythagorean theorem, the golden ratio. You can see the smaller ones getting bigger and bigger and bigger. Like you can imagine the spiral here coming out from this direction. Start going this way, I suppose. And you can see the Great Pyramid and I guess the Sphinx in this case. You can see all the different spirals and whatnot around it. You can also see it greatly in art. I believe Galileo also did it in his um, painting of I'm blanking on the name, Last Supper. I don't have an image of it, but you can see the spiral goes starting from the Mona Lisa's nose and going outwards like so. You can also see it in here in this sort of this. I believe this is like a music note. I'm not too familiar with music, but you can see the spiral sort of look. Um, it's also everywhere in nature. You can see it so far out in nature. You can see it in this rose, along with here you can see in the seashell as it goes out the spiral. It also is shown in much bigger and smaller areas like DNA strands. The phi is shown to be in between the two grooves. I don't have huge details on it. Um, is the ratio between two grooves in the DNA spiral. It's also found to be the distance between two planets, or the orbital distance, like between here and here, is phi, along with here and here, and so on, between each of the planets. So, saying essentially the distance between here and here, or the distance between these two. I don't know, but or between the planets. Sorry, not the sun. See the distance here is equivalent of that. I guess this would be 0, 1, whatnot. You can see it kind of stretching out as you go. This is the equivalent of this plus this, and this is equivalent to this plus this, and so on. Now, probably asking, why is this so interesting? Well, the Fibonacci sequence is really, or the golden ratio is really interesting because it's physically appealing to the human eye. Like, we actually have a sort of attraction to it. I've heard somewhere that people actually like seek out, like, you can notice this little distinct little pattern, like in what we call perfection. It has been often called the most beautiful number in the universe. You can see it here. Like, I mean, you can see it, this large spiral right here. There's loads of spirals in here, and I mean, the most notable you can see is the earlobe. It's honestly, it's like considered perfection. Like, people find it very attractive. Here's a fun little interesting fact. There was an episode of the TV show Criminal Minds, which is where FBI agents study serial killers. In one episode, this killer is completely obsessed with the Fibonacci and the golden ratio, and devotes his entire life around it. He finds people that are physically perfect, like, or women that are, like, to him are perfect, like the golden ratio fits them perfectly in so many different ways, and he kills them. He kills in specific order as well, like specific to each town. He goes 1, 1, 2, 3, 5, and he sticks to that. It's actually how they eventually figure out his dastardly plan in the end, that he was not going to kill a bunch of people, but only could kill a certain amount of people. He was forced to kill the next amount, would have been 8. He could not kill more than that. Just a little interesting thing. And that's really all I have. Here's some references. Most of them are just for the images. I have some for the sources, the like references I used, but that's about it. So if you have any questions, please feel free to ask while I'm in class. This is being uploaded to YouTube. Bye.